if you need to. All right, so let's go ahead and get started. So we're going to talk about building healthy soils with sustainable and effective amendments. It's one of my most favorite topics. So I thought it'd be nice if you could get to know me a little bit better and kind of where my perspective and thoughts on soils come from. So I'm a small farm specialist at Utah State. I'm a soil scientist by training. Soil physics is actually my background, what I love the most. And I've been working on cut flowers since I got here as a high value crop. When we do everything from season extension to soil fertility, and I've been doing a lot with irrigation in the last couple of years. But in my outside of work, I'm an avid urban homesteader. And I used to run an organic community garden. I do conventional ag research. And then at home is where I like to just have a lot of fun. I get a lot of ideas. So I keep chickens and rabbits. And every year more, here's a drone shot of my house getting flood irrigated this spring. Every year there's more gardens that go in so that I can increase my food production. And so it's a great joy. So when I get to talk about soils, I do it from a research perspective, but also as an enthusiast myself. My understanding is that most people who are registered today are gardeners. And so I'm going to generally use that perspective as we talk about soil health today, but I'll try to touch on farming a little bit too. And I also want to try to cover the different systems that we have and different ways that we can garden from organic to conventional methods and try to touch on best practices across the board. All right, so getting started here. We're going to talk about soil health really as the basis for all of our discussions today. It's all going to come back. The reasoning for why we do certain things and not other things really comes back to soil health. And so it's important. I want to make sure we're all on the same page to start. And so I want to just get into the nitty gritty on soil behavior. Why do sands and clays act the way that they do? And that just helps inform then what things we can do to improve the challenges associated with those different textures. Okay. So the other thing that I want to achieve with that is that we can talk about different challenges that come up. We might even talk a little bit about what products you can buy. That's telling us, we're discussing what's happening in the soil and what we can do. But my goal is to also describe why or the processes behind these soils, because I won't always be in your back pocket. So when you're at the store making a decision about a product, should I buy it or not? You can think through, well, this is how the soil behaves. This is what I know I need for my soil. Is this product really just great advertising, or is it something worth buying? And I like taking that approach because it's impossible for me to know every product that's out there. And so when we have these webinars, it can be easy to just get questions about, should I buy this? Should I buy that? And I really don't want to talk yes and no products. I want to keep it more broad and specific in terms of thinking about the why behind it so you can reason that out yourself. So we're going to spend time on soil behavior, and then we're going to get into the amendments. I want to talk about proper soil testing and selection of amendments and fertilizers, and just how to optimize that for both environmental sustainability and for plant growth. And then we'll talk about cover crops and residues, compost manure, and so forth. So that's the goal today. And also through all of this, I just want to make gardening simple. There's so much out there that's we're being hit with on, you should buy this, you should buy that, you should try this. Let's just keep it simple and talk about what does the soil need, what does the plant need, and go from there. All right, so this is my perspective. This is my lens when I'm giving recommendations to people, and that is really this stepping back and thinking about soil as a workhorse. There's such appreciation for it because we ask the soil to do so many different things. This is just a short list of some of the things that the soil does for us and for our plants and for the environment. And so I like thinking about soil health as where all of these goals come together. So soil can help protect the environment. It can be productive in terms of growing plants. And then there's also, that we need to conserve the soil as well. And so where all these come together is soil health. And so that's really the basis for this talk. And on top of that, my goal is that we really have a focused, optimized approach. And this is a little bit selfish, admittedly, because I get a lot of emails about what's wrong with my plant. And so when I see something on the back end, it can be expensive to correct. And so if we can hit it on the front end and avoid a lot of the consequences, that's very helpful too. There's a lot of things that we can do to the soil once or twice, 3 times, maybe more, and there's not necessarily going to notice a difference or see that it's had an ill effect on the soil health. But later on, it can really come to a head. And that's again why I think it's important to talk about this on the front end. And so it's really this balance of knowing what to feed our soils and those systems, what does it need, and no more, and going at that. Because another thing with gardening in particular, or small scale farming, is that when there's not a lot of land, it's more limited, there can be a tendency to love it to death as well. And so we want to avoid that too. So that's our lens going in. And so let's talk about our first main topic, which is the soil behavior and what to do about it. And in particular, Mary shared that there was interest in knowing what to do about a sandy soil, what to do about a clayey soil. Okay, so I want to acknowledge, though, that there's folks from not just Utah on this webinar, and I'm really excited that we get to talk across states here. And it brings me to this important point that I want to step back and have this appreciation for soil and how different and ranging it can look and behave across the country and across states. And even within a state, within a valley even, the soil can have tremendously different properties. And so this is my short field trip across the US. We start here in the Midwest. That's where I'm from. Maybe you can already hear my Wisconsin accent coming through. So here, far left, the Midwest soil, typical Midwest soil. That's a profile. Soil scientists really like to dig profiles and analyze the different layers of soil, classify them. And so these are tape measures in soil pits. And I don't know if this works out with a large group, but feel free if you want to enter it in the chat. What do you notice about these soil profiles going across the screen? Anything stick out to you? And while you're entering those, I'm just going to mention that, so this tape measure is in feet. So 1, 2, 3 feet are in the picture. Something that sticks out to me is the color of the soil on the left. It's this black, rich color. That's organic matter coating the grains of soil. So organic matter is plants and animals that have lived and died and decomposed and become stable parts of the soil, coating the individual grains. So there's a lot of organic matter. It's a very rich soil. People are mentioning that in the chat right now. Yeah, you're nailing it. Absolutely. I would say, so this topsoil layer or the A horizon, gosh, it goes at least 2.5 feet deep, and we're flirting with 3 feet. All right. So that's a very rich soil. The parent material or what the native vegetation was for before humans settled was a tall grass prairie system. And so in that environment, one rule of thumb we can think of with plants is however tall they are, that's how deep their root system goes. So a tall grass prairie is going to have a very deep root system. It's going to have a lot of fine root hairs that turn over very quickly. And so it helps build the organic matter up in the soil. It's a wet, humid environment, which supports a productive plant life. Then as we head west, what do you notice about the soils? So we're going into eastern Colorado, into Utah, Intermountain West, semi-arid grassland. That's central Utah. Here on the far right, we've got our tape measures again. And you can see that the soil is a little bit less black, right? It's more of a brown, kind of rusty color with the topsoil. It's also, we're no longer flirting with 3 feet deep. We're at, here in Utah, we're maybe 1.5 feet. That's pretty good to get down to 1.5 feet. So as we head west, there's nothing wrong with our soils at all. It's just that as we head west, there's less water, there's less precipitation. So snow and rain in over thousands of years, that just supported a less productive plant life. It's not worse or anything like that. It's just a less productive one. So it has had fewer inputs over time. So a short grass prairie soil, that root system's not going to go as deep. And so that topsoil layer isn't going to be as deep. Those organic matter inputs aren't going to be as deep. And then when we head here into Utah, it's that more so. So there's less organic matter input, so there could be less fertility. But there's also less precipitation, which means we can't really wash things out of the soil. So there can also be salt and lime buildup in the soil as well. We're going to touch on a lot of this throughout the talk today, but I bring it up because so many of our garden and farm recommendations are coming from out of state, which is kind of funny because a lot of you are out of state, so I'm out of state to you. But a lot are coming from the Midwest, they're coming from the coasts, and those soils couldn't be more different than ours. And so there's things that they might be able to do and get away with, but we really have to be the best farmers and gardeners because there's so many more things that we have to be aware of. So this slide is up just to say, be careful. It doesn't mean the recommendations aren't good or applicable, but in some cases it can lead to challenges down the road. All right, so we have a great range of soils. I'm going to try to talk across the Intermountain West and into Montana, Idaho, Nevada, Utah soils and what I know about them. But we'll keep that in mind here. So now we're gonna get into it. We're gonna zoom in. If I were able to take a scoop of soil and hold it in my hand and use a magnifying glass or more to really zoom in and see what does it look like? How does it behave? This is kind of what I would see. So I like this cartoon here with the different tiny soil particles that are grouped together into what we call aggregates or chunks in the soil. And that would be if you grab some of your soil in your hand and kind of used your finger to spread it out, it naturally kind of falls apart into chunks or aggregates. And I think a yellow sponge, a cleaning sponge, is a perfect analogy or way to picture a soil beneath our feet, in that yellow sponge material is like the mineral content of the soil, the sand, silt, and clay, and then all of the holes in the sponge is the pore space, which soil has too. So in between these mineral particles that are aggregated together, there's pore space that can be filled with ideally water and air, not just one or the other. So if it's totally filled with air, that's a bone dry soil. And if it's completely wet, we call that saturated, and plant roots can't breathe. So this is just a pie chart of what would be ideal from a plant's perspective. The mineral content of the soil is going to be about half or 50%. And then the other half is pore space that's filled with that water or air. And I always think that's amazing to picture that whatever we're standing on, only half of it is actually solid. The rest is all pore space. So like that sponge, if I pull it out from underneath my kitchen sink, I'm ready to start cleaning. It's dry because it's been a minute since I cleaned. All of those pores are filled with air. I dunk it into a bucket of water, and suddenly all of those pores are filled with water. It's saturated. It's 50% water, 50% sponge material. That's too wet for plants. They can't breathe if there's not air in there. So that's not our goal with irrigation, to saturate it necessarily, other than in specific circumstances. But then when I'm ready to clean, I take that sponge out of that bucket of water, I squeeze it, water comes out, and then what I'm left with is a moist sponge. I'm ready to clean. That's also really what plants like too, because when the soil starts to dry or drain, the water leaves the large pores first. So there's all these different pore sizes in the soil. And so when those big pores empty of water, there's air then for the roots. But then the water remains in these films around the particles. And if we're really lucky, about 5% of our soil might be organic matter. Here in Utah, in northern Utah, our natural organic matter percent is around 1.5, maybe 2%. We'll see that a little bit, maybe even in the Park City area. But then as you head south in the state to southern Utah, the natural organic matter content would be about 0.5%. So another focus today is we're going to talk about adding organic matter to the soil because it does a lot of wonderful things that I'll elaborate on soon. So getting back to soil texture, or that mineral content, that sponge material, that yellow sponge material that makes up half of the soil, the mineral content is simply just how much sand, silt, and clay is in the soil. Those are our primary particles, and together they are soil texture, and there's many different textures that we could possibly have. But I want to take a moment to just picture what sand, silt, and clay look like, because it does affect some of their behavior. So sand is the largest particle in the soil. You can all picture that, like beach sand would be an example. If you were to take some soil in your hand and moisten it and have it between your fingers, if you feel any grittiness, that is the sand component. Silt is also a spherical shape, but it's smaller than sand. And then clay has a totally different shape than either sand or silt. It's actually kind of a platey shape. So I like to think of it as my notebook, um, that sort of shape of a notebook maybe. But then on top of that, it has all of these layers in it. So it's a really tiny particle, but it has tons and tons of layers, sort of like my notebook has, hundreds of pages in it. Clay has a lot of layers, and that adds to its surface area and its ability to hold water and nutrients. So with sand, silt, and clay, there's a certain amount in everyone's soil, and we use what we call a texture triangle to determine what the texture is based on the percent sand, silt, and clay. So each corner of the triangle has, represents each of those textures, and then you can figure out what percent sand, silt, and clay you have to figure out your texture. This is the actual soil texture triangle. You can see these are the different textures then that we name. So sand, loamy sand, sandy loam, silt loam, silt. And really, ideally, where we want to be is in the loam category if we can. If you naturally have a loam soil, it really is a best of all world situation because you have sand, which can help with drainage in the soil, but clay, which helps hold on to water and nutrients. Okay. But you really don't have to necessarily be in the center of the triangle to have a great soil. Once we know what the texture of soil is, we can work in that capacity. I want to point out though, on this texture triangle, so you can see, so on the bottom here is sand. So it goes from right to left of 0 to 100%. Clay goes up the left side of the triangle and silt is down the right side. So once you have your 3%, you just find where they meet, and that's what the texture is. The USDA actually has an interactive soil texture triangle. If you Google it, it'll come up, and it'll just plot what your texture is for you. But if you notice here, the percent sand, you have to have over 85% sand in the soil to just be considered a full-on sand. On the other hand, I only need to have maybe 55% clay in the soil for it just to be considered a clay. Look how much of the triangle clay takes up. And that's because clay has a really strong personality. A little bit of clay goes a long way, as I'm sure most of you have felt if you're working with a clay soil. And so that's what I want to talk about next is why is that? Why does clay have such a strong personality? It's really tiny compared to the other particles. So we have to do a little bit of chemistry, but I promise it's a couple slides. We're in and out, and we'll try to make it as painless as possible. So clay particles are really tiny. There's some diagrams here of it comparing the size of clay versus the size of 1 grain of sand. But I like this cartoon here because there's a bunch of minus signs on what we're calling a yellow blob or clay particle. So clay has a negative charge to it. Sand and silt have no charge. So let's just keep that in mind, keep it in our back pocket, and skip on over to water. So this is what one molecule of water looks like. I like to say it looks like Mickey Mouse with those hydrogen ears. So H2O, one oxygen and 2 hydrogens. And so with the chemical structure of water, water has a positive and a negative charge. So the hydrogen side, the Mickey Mouse ear side is positive, and the oxygen side is slightly negative. So it has a charge. I'll put this in the other back pocket. Then we come back to clay. So clay particles feel really sticky. If you had some clay in your hand and it was moist, you could feel it between your fingers. And by the way, so sand is gritty, clay is sticky, silt feels greasy or silky. It's a neat feeling. So clay is sticky. It's got this negative charge, surface charge to it. And here's water. The positive side of water, those Mickey Mouse ears, they really, really, really want to stick to clay. So positive is attracted to negative. Now, what's happening here is not magnetism, but I think that's a good analogy. I don't know, as a kid, I had magnets, and there's a positive and a negative side. And so when you put the two positive sides together, you can feel it repel. If you put the two negative sides together, you can feel them repel. But a positive and a negative side, boom, they stick together. It's like love at first sight. So water sees clay and it wants to stick to it really badly. If water sees sand or silt, which has no charge, it's like seeing a stranger walking down the street. There's just nothing there. It doesn't want to stick to it. It really wants to stick to clay. And so this is why clay can be so challenging, is that it hangs on to water extremely well. And you can kind of picture how these molecules would stack. Very negative surface charge to clay, so the hydrogen side of water sticks to it. It's got the oxygen side on the, facing outward, and that's negative. So then more water can kind of piggyback onto that. So it has this negative charge. And then I mentioned that it also has a different shape. It's got a shape like my notebook, so kind of rectangular, but then it has a bunch of layers like the pages in my notebook. And each of those layers can hold water and nutrients. So it seems like clay is really tiny, but it actually has far more surface area or area to attach to than sand or silt, because it has all of those layers within it. And that can make it difficult for drainage too. So we're going to talk more about plant nutrients coming up. This is putting the cart before the horse a little bit, but I wanted to show a few plant nutrients in their elemental form. So magnesium, zinc, calcium, iron, copper, molybdenum, those are all listed here, and you can see their charge. Here's a lot of these are 2+, 3+. So these cations, a positively charged atom, they want to stick to clay too. So clay can have a pretty high soil fertility because the plant nutrients want to stick onto it. Just like water, when nutrients see sand and silt, there's not an attraction there because sand and silt have no charge. So my trick question here is, what about nitrate? That's one of two forms of nitrogen that plants can take up. When nitrate sees clay, what do you think happens? Throw it in the chat. See, am I caught up down here? All right, no one's brave enough yet. Let's think on it. So negative charge. Yeah, you nailed it. It repels. It doesn't want to stick around. I hope I remember to talk about how naughty of a nutrient nitrogen is, but that's one of the reasons it doesn't want to hang on. It's got that negative charge. Number one plant nutrient doesn't want to stay where we put it. So bringing this all together, why does soil texture matter? Well, it matters because it influences so many, honestly, it influences everything. So I like to think about it, or I think we all think about it a lot in terms of the water dynamics in the soil. So how fast can water infiltrate or go into the soil profile? And how long is that water going to store in the soil profile too? And this leads us to different irrigation regimes. So up here in Logan, where we have a research farm, we have a silt loam soil. And I've done research in Salt Lake where it's a sandy soil. And even if I'm doing the same crop in both of those soils and testing the same thing, our irrigation schedules are very different. So in a soil that has more clay, I'm not going to water as often. But when I do water, it's going to be a gentle soak, so a slower flow and a longer duration, because I know that the more clayey soil can handle it. But then I'm going to back off and I'm going to wait for a while because it's going to hang on to that water really well. But if I have a sandy soil, my goal with irrigation is just to keep that water in the root zone. If I water more than that, it's draining, and that's not going to support my plants, and I'm going to be spending more money on water and wasting water. So with the sand, I want to moisten that root zone. So I'm going to apply irrigation. It's going to be for a shorter duration. I'm not going to run it as long, but I'm going to do it more often because I know that sand can't hang on to the soil. Similarly, soil texture influences the soil fertility. How well can that soil hang on to nutrients? So if I'm setting, the same crop, I'm going to add my nutrients maybe a little bit differently. Maybe up here, I'm going to add my nutrients twice, half right before I plant and half when the need is going up again. But maybe if I'm in a sandy soil, I'm going to fertigate it in and maybe divide that application up over several weeks. So that's what soil texture influences. And if you're interested in knowing exactly what your texture is, there's a lot of ways to do it. You can send in a sample to a lab. That's the most precise way to do it. These are other ones that you can Google online that I've got listed here. So the jar method, you use a quart canning jar. It's really simple and easy and fun. I can also send you a PDF handout on how to do that too. You can hand feel it. That's what some soil scientists specialize in. They can actually hold soil in their fingers and come up with the percent sand, silt, and clay. That's not my specialty in soils, but a lot of folks are amazing at that. And then there's also the USDA and UC Davis have a soil web survey. So if you Google that, it'll come up and you can put your address in. The UC Davis one's really user friendly, and it'll actually plot what the soil series are on your property. But that's a little bit of a broad brush stroke. So the boundary for different soils isn't exactly plotted. So just keep that in mind, but it can be a really great free resource. Okay, so what to do about it? Managing for organic matter is the best way to manage for soil texture, no matter what side of the triangle you're on. So a lot of times there's questions, I have a really clay soil, should I add sand to it? No. I have a really sandy soil, should I add clay to it? No. The answer is in both cases, add organic matter. Organic matter, organic matter, organic matter. And there's a lot, and we're going to spend a lot of time here talking about how to add organic matter to give the soil a healthy diet so that it's not all coming from one source. So some of the things that organic matter does, remember we said organic matter is plants and animals that have lived and died and become part of the soil. So it's decomposed, it's relatively stable. In the case of sand, organic matter can coat the sand particles. And the beautiful thing about organic matter is that it has a positive and a negative charge. So suddenly sand can start to hang on to water and nutrients because it's coated with organic matter. When it comes to clay, though, what organic matter will do is it helps develop better structure in the clay. So all those little tiny clay particles that have such a strong charge, such a strong personality, it can start bringing them together into little aggregates. And that's what my cartoon is right here. So you can picture all of these primary particles being bound together into bigger particle sizes or aggregates with organic matter. So it's kind of like this glue. And what that does is it creates highways in the soil. So if I didn't have that, for example, it's kind of like driving in a car. If I wanted to drive across the state, I could take all of the back roads and honestly have a wonderful time. But it would take me a really long time to get through the state, right? Many, many hours. But if I hop on the freeway, boom, I can shoot through the state pretty quickly. And that's what's happening here. So the water, if it's going to be in all these tiny little pore spaces trying to move through, that's going to take a really long time. But now when these aggregates form, because of the organic matter, we've got highways in the soil or macropores. And that allows the water to take a highway into the soil and hopefully through the root zone in a clay soil. So organic matter is the answer for sandy and for clay soils. It just does a lot of really beneficial things. And we haven't even touched on nutrients, more just the water end of things. But we'll talk about nutrients now. So testing amendments and fertilizers, oh my. Plants need 14 mineral nutrients. There's a lot of fanciness out there about what we need to be giving our plants, but at their basis, they need 14 mineral nutrients. All plants need these 14 mineral nutrients, and if one of those nutrients is deficient, then the plant can't grow to its full potential. So if I don't have enough nitrogen, it doesn't matter how much phosphorus I put on it, it's not going to go to its full potential. And the soil is really special because it behaves as a nutrient bank. And actually, we don't have time to get totally into this, but you can think of it as a bank that has a checking account, a savings account, and a custodial account. The custodial account of nutrients, that plant can never dream of touching. But it can withdraw from checking. And when checking gets low, the soil can replenish that from its savings account, which is organic matter in a lot of cases. So the soil is an amazing nutrient bank, and plants are going to take up from the checking account, so what's readily available, and they can only take up specific forms of nutrients. So the ones that I showed, the Mg2 plus and NO3 minus, plants have to be really specific. If they could take up nutrients bound to anything, then they would be in a lot of trouble taking up things non-discriminately. So they have to have a specific form of the nutrient. And but beyond that, a goal is that there should be sufficient nutrient levels in the soil. We know what those optimum rates are for many of our crops. But if the nutrient level is above that, there's no plant benefit. The plant will not grow better, and actually it can be a negative. It can increase the salinity in the soil, and that's another theme here today. So and I also just, from my perspective, when I showed the soil health slide and how that comes together with all of the things we expect from our soil, environmentally, having excessively high nutrient levels isn't sustainable. We lose those nutrients to the environment, then it can pollute our water resources and so forth. So that's why it's important to be aware of nutrient management. My picture here is of a dahlia, and this is a trick picture because you can see that there's yellowing on those leaves. And so if I were to look at this and say, oh, there's some yellow, I bet this plant needs some nutrients, that would be wrong. This one actually has a disease. It's got a virus infection, and that's why it has the yellowing. So relying on visual symptoms alone can be problematic. They can be unreliable because it might not be a nutrient deficiency. You can potentially get them mixed up. And also for some crops or for crop production, if we're trying to optimize it, by the time the visual symptom shows up, it's too late to fully correct it for this season. So you might not reach the yield threshold. And so that's why we advocate for soil testing. You can know what's in that bank before you start withdrawing from checking. So here are the nutrients. They're grouped into two categories, macro and micronutrients. Macro means big, micro means small. So macronutrients are the nutrients that plants need in the greatest quantities. And I highlighted nitrogen, phosphorus, and potassium, NPK, because those are the three primary macronutrients, or the three nutrients that plants need the most, and we need to keep an eye on the most. Sulfur is highlighted here too. It's in italics because this deficiency is coming up more. It's a fun story behind that, but that's one to potentially keep an eye on. And then iron and zinc are also italicized because here in the West, we tend to have alkaline soils, or soils with a higher pH. And at a high pH, we probably have plenty of these two nutrients, but they can get locked up and they can become unavailable for plants. So those are ones that but the rest, the soil pretty much takes care of and has a lot of in it. Okay, I'm not going to go through this slide, but for anyone who really wants to like dive into plant nutrients and get excited, I just want this as a reference slide for you. You can see what the plant available form of the nutrient is, and then what that nutrient specifically does for the plant, but beyond what we need to talk about here today. So then lastly, before we get into the nitty gritty of what to add, let's just talk about some definitions to all be on the same page. So if I were to walk down, and this is also because I prefer not to answer specific questions about brands and products. So we'll just do this as a general example. I'm not promoting any of these. They're just varying examples for me to show. So truly, when you walk down the aisle with fertilizers, there's just so much to pick from. So products intended to supply plant nutrients or fertilizers have three numbers on the bag, and it's always in this order. NPK, it's the percent nitrogen, phosphate, and potassium, potassium, and it's always in that order. So sometimes you have to look really carefully to find it on the bag. Companies spend a lot of money on artwork so that we just want to grab it, but the most important thing is to find out what the guaranteed analysis is. What's actually in this, and do I need it, is the question that I want to ask. So this one here in the middle, this Dr. Earth, is especially hard to find, but it's a 463. So there's 4% nitrogen, 6% phosphorus, and 3% potassium. And so just if you want to impress your friends at a party, there's actually a way to distinguish if it's a fertilizer versus what we would call an amendment, but that's getting in the weeds a bit. So on this, how much nitrogen is in a 10-pound bag of urea? And here's an example of urea right here, where it's 4600, so 46% nitrogen. That would mean there's 4.6 pounds of N in that bag. Versus if I use blood meal or blood meal, or I guess we could just use this Dr. Earth. If I had a 10-pound bag of Dr. Earth and it's 4% nitrogen, that's going to be a lot less, right? Than if I'm using urea. So urea is more concentrated. The second part of the definitions that I wanted to bring up is turn the bag or the product over and read the fine print. So there's words like available or soluble, and that means the nutrients are available right away. They're available in that plant available form, remember, because plants have to be specific about what they take up in their roots or they get in trouble. So these are nutrients that are immediately available. That also means that they might not stick around in the soil as long because nitrogen, and speaking about this in terms of nitrogen's naughty. It doesn't want to stay in the root zone. It wants to volatilize, it wants to drain, and so forth. So soluble nutrients are available right away, but they also might like to leave sooner than later. So here's examples. Water, let's see here. Yeah. Total nitrogen, water insoluble, ammoniacal, water soluble. There's a lot of different ways to say it. Ammoniacal nitrogen also means it's available right away. Water insoluble means it won't dissolve into water right away, so plants can't take it up. It's not available right away. Or same with our slow release products. And so there's pluses and minuses with both forms of nutrient. If I'm planting and I know my soil needs nitrogen, I want there to be available nutrients right away, but I also want them to last for a while as well. So slow release can be a really great form. So last definition then is organic, because we say that word a lot, but it means different things. We've already talked about organic matter. Then there's certified organic, which is totally different. It's a USDA program in terms of what we're picking for our inputs. And then there's organic chemistry, and that's any compound with carbon in it. So enough on the definitions. Let's get back to soil testing, because that is going to inform which product to select. So soil is really this black box. We walk on top of it, but what really is going on in it? And testing informs. It tells us where that status is at. Ooh, I've been talking a lot. I got to move ahead here. So soil testing helps us optimize yield and environmental sustainability. It's a black box. It helps us avoid deficiency as well as excessive levels. And in terms of what soil test to pick, it's named different things at different labs, but it's something around routine or basic is typically what it's called. Land-grant universities, I think most of them have a soil test lab that you can send samples to. There's also private labs. I just say pick one in your state, because our soils are so different across the US that we have different soil tests based on that. And if you work with your county extension, they'll know what soil test they should use. So a routine test will give you the salinity, pH, phosphorus, potassium, and texture. If you find out that you have a high pH, you might want to check for micronutrients. And there's certain urban risk factors that you might want to look for in contaminants. And I've got a fact sheet that you can look at to learn more about that. So junk in equals junk out. So be sure to take a good soil sample. There's a lot of different ways to do it. My quick response is to make sure that you take more than one sample. So if I go in my garden, take a sample and send it in, it might not be representative. Maybe one of my dogs came and peed right there, and it's going to throw things off. So take a few samples. There's a lot of guides on how to do that. Just try to be random about it is the main thing. And then I shouldn't treat my entire yard the same way, because my gardens I've treated differently over time. Or here's a picture of our research farm where we're growing different crops. Some of them are undercover, some of them aren't. And so if I went and took a soil sample from each of these zones, mixed it together and sent it to the lab, it would just give me the average. And so if you can, think about zoning your property. This fact sheet here, if you put the title into the Google, it'll pull it right up. And it'll talk about things to think about for creating those zones. More information on soil sampling can be found here. And again, I'm putting the titles up so that you can just type them in and pull them up. So with soil testing, this is an example of a soil test report, and these are things that I would look at right away. I always look to see, here in the West, I always look to see what the salinity is before I start giving recommendations on amendments. And so above 2 is going to get flagged by the lab. And this one down here is what I see the most, where there's a high salinity. Phosphorus and potassium are off the charts. They're very high, but nitrogen is needed in a lot of cases. And so in that fact sheet that I showed before about soil testing, we have this table about salinity thresholds that once our soil gets above that, doesn't mean the crop won't grow, but it's going to have some stress to it and it won't reach its full potential. And it can be really surprising what the soil levels are at. So my house, the previous owners were not outdoors people, and I had my soil tested right away, and it was at 1.75. So I was right on the threshold right away, and I knew I had to be careful with my amendments. More information about what to do with low nitrogen, but we generally have to add it each year. I'm going to move ahead so that we can talk more about different amendments like compost and cover crops and residues. But the main thing that I want to get across is that if only nitrogen is needed, which is what I see the most here for garden soils, only add nitrogen. So look for product labels that NPK. We want that first number to be bigger or higher and the other two numbers to be 0 or much lower than the first one. Otherwise, there's an over application of these other two that we don't need. Phosphorus is an environmental contaminant, and potassium adds, even though it's a nutrient, it adds to the salinity in the soil. So this is that, again, that fact sheet that walks you through it, and I use a conventional and inorganic fertilizer source or amendment source. I'm going to not go through this, but I'll leave it to you as a reference that we can group our crops by their nitrogen demand, and that can be a really helpful way to organize them in the garden too, so that you know one area needs more or needs less. And so it's been really well developed for vegetables, to some extent fruit, and I'm trying to work on cut flowers here so that we can also figure out their nitrogen demand because it varies quite a bit. And then lastly, thinking about the timing of nutrient application so that adding that application or that nutrient relates to when the plant needs it. So when it's a real little baby plant, doesn't need a lot of nutrients, but then as it gets bigger, there's this graph that shows it with corn. As corn grows, it's going to need more nutrients, just like us, as like a teenager is going to eat far more than an infant. Same with these dahlias. When they're all in bloom, they're creating tubers, they're going to need a lot more nitrogen than when it's a little plant. Okay, so fertilizer is one way to achieve the nutrient needs of the soil. Amendments are another, and compost and manure are one of my favorite topics to talk about. And I think it's something that people really like to add a lot. So when I got here, I went through and I analyzed all of the data from our soil test lab on manures and compost to kind of get baseline values depending on the compost type or the manure type. And then I reported them in the fact sheet, which I'll show the title of on the next slide. But here's just a few rules of thumb with the nutrients that come with the compost. I'm so sorry to move fast here. I just have so much to share with you. But thinking about manure, you can think about compost this way too, that ideally we want more nitrogen than P and K, but across the board, it's usually about equal parts NPK. And low salt is also key. So the salinity here, you'll notice chicken manure, 16. Remember, our magic number is 2. We don't want to be above that. And while there's some buffering in the soil, repeated additions of manure or manure-based compost is going to bring that salinity up. And the reason for it, here's some poop from my coop. You can see that white on the manure, that's their urine, and it's really concentrated and high in salt. And so keep that in mind when you're thinking about different composts or manures to add to the soil. Careful on the salinity, but then also keeping in mind the nutrient content. So one way to approach manure and compost use is to use it to reach your phosphorus need and then supplement the N. That's what I do at home because you're going to need more N than P and K. If you go to that fact sheet, there's a whole calculation. There's an Excel file too that you can fill out and it'll calculate how much you can add, but that's a picture of it. What not to add is these. So these all count as salts in the soil, and you'll notice a lot of them are plant nutrients too. These are what the products are called. So gypsum is a question I get all the time. Same with Epsom salt. All they are is calcium sulfate and magnesium sulfate. Calcium, sulfur, magnesium. My question is, do you need that in the soil? And if not, don't add it because it's just going to count as a salt. And typically here in the Intermountain West, we have copious amounts of calcium and magnesium because we have so much lime in the soil. The problem with salt, even though a lot of plant nutrients are salts, is that they inhibit growth by causing a chemical drought. And we're lucky we're out of time, because I have a very gross analogy with a neti pot to explain how that works, but we will bypass that for now. There's visual symptoms with it. And then again, these are those soil test thresholds of staying below 2. So solutions to salt problems are to control the source. 9 times out of 10, when we're trying and I'm working with someone to figure out where it came from, it's over application of manure and especially compost. It's putting too much on the soil at once. It's a marathon, not a sprint with soil health. We want to add organic matter, but not all in one year. There's a vintage fact sheet that talks about how to take care of a high salinity soil. And essentially what has to be done is it has to get leached out with good water. So saturating the soil and adding 6 inches of water to it on top of that reduces the salinity by 50%, but you need about 2 feet of water to reduce the salinity by 90%. And this fact sheet talks all about that. But one little water saving trick, this is a picture of one of my gardens. In the wintertime, our soils, and when the snow melts, our soils are going to be as wet as they will be for the year. So they're already almost saturated. And so then it's a good time to try to leach out the salts, because you've already got a head start with moist soil. So like I mentioned before, organic matter builds a resilient soil. We talked about it in terms of water movement in the soil. And so I want to bring up that compost and manure can be one way to do it. Cover crops are yet another. And the benefit of cover crops is that there's not salinity to contend with. And so they can do amazing things in the soil. We've got a few fact sheets here at Utah State about cover crops, and Western SARE is a tremendous tremendous resource with even more resources on cover crops. But there's a few groups of common selections that you can pick from. One cover crop can't do all the things. And so kind of picture what you want the most from those cover crops. And then as gardeners, we usually are limited on land. We can't necessarily take a garden out for a year. So I like to think of clever ways to incorporate cover crops. I like to follow my onions with cover crops, because those come out relatively early. So I have the whole fall to be growing a cover crop. The different ways to do that. We can talk more if you're interested. You can also add mulches. I really don't like naked soils. It's subject to wind erosion and so forth. So there's a lot of different residues. Be creative. Give the soil a healthy diet. Here's just some examples. And more thoughts on residues and just thinking about that carbon content. I want to quickly plug Washington State University, Andrew McGuire. If you Google him, he's got an amazing blog. He writes articles about the things that we really care about, like, do you need to add microbes to the soil? Answer is no. The soil's got plenty of them, and if you build it, they will come. So what I mean by that is we have plenty of bacteria in the soil, fungi, and so forth. And if you create a healthy soil for those microbes, they'll flourish. So adding organic matter to the soil, managing nutrients. And if you want to read more about that, even in cover crops, different combinations, his blog is really fantastic to read. Okay, I don't know that we're going to have time to talk compost and how to compost, but if you want, I'm going to go through it quickly. And if you want to spend more time in the Q&A, we can talk in depth about composting. It's one of my most favorite things to do. There's a lot of ways to go about it, but it's one of the best ways to upcycle waste products and then return it to the soil and build soil health. So I have a slide here on compost ingredients. We've got 2 categories, brown and green materials. Brown materials have a lot of carbon. Green materials have a lot of nitrogen, and you need both. Bacteria in your compost need both to break it down into organic matter for the soil. There's a lot of things not to add to compost, though. Wood, it's not that it doesn't break down, it's just that it's got so much carbon, it takes a long time for it to break down. If you have a chipper mulcher, though, at home, first off, you are absolutely living my dream. But second off, you can probably compost wood then. You just have to break it into really little pieces, and then it's fine. Meat products attract creatures, but it is high in nitrogen. Salted food, which usually we cook with salt, not using that because the sodium and chloride is going to add to your soil salinity, and sodium is not a plant nutrient even. So that's the reason for that. no diseased plants, or you'll just keep propagating that disease, and then synthetics, of course. And then I put a picture of everyone's favorite weed here, bindweed. I recommend not composting it because we don't get our home compost hot enough to kill it. There's site considerations to think about, and size, location. This is my composter. I've got 2 bins that are 4x4x4 in size, and that works really well for me. And the idea is that I have 1 active bin that I'm adding to and 1 bin that's finishing up. I'd love to talk more about that if you're interested. A lot of different forms that your compost bins can look like. It can be super simple. It can be store-bought. And then when is it done? When it doesn't smell bad. You shouldn't be able to identify what's in there. But the main thing is that it doesn't heat up anymore. So an active compost that you're turning, every time you turn it, if the moisture level is correct, it's going to heat up within a couple days. It can be hot to the touch. But once it stops heating up, that means that it is done and ready to apply. And if you're like me, I just don't have time. And so I just try to apply it every spring. So I just hope for a year turnaround time. But I've heard of gardeners who can get their compost fully turned around in 15 days because they're managing it so carefully. This one's a fun one. We had a group of students who were testing the salinity of different composts, and I'm not going to reveal what brands these are. But so we were testing these, looking at NPK, carbon, salinity, and look how high some of these commercial composts are. That is magic numbers 2. Now this mysterious home garden compost, this one's mine. I'm really proud of it. I've got chickens, I've got rabbits, but I'm balancing it out, and my salinity is only 3. So it's above 2, but that's not bad for a compost. And so I just want to say that you can create, much like when we cook our own food, you can create what's better than store-bought. So consider composting if you're interested in it. All right, so we talked about a lot of things and I plowed right through. I wish I had more hours with you. But to summarize what we've talked about, inducing soil structure through organic matter is the best approach for managing clays and sands. So it coats the sand particles, which gives them a charge and allows the sand particles to hang on to water and nutrients. And in the case of clay, it helps glue those itty bitty particles together into bigger ones and create highways in the soil. Soil testing is a great way to figure out what the soil and plants need. We'll say every 1 to 2 years for annual crops, every 3 to 5 for perennials. At our research farm, we test 1 to 2 times per year. But I would say even if you just test once, just take a look at what's inside the soil. It saves so much on the back end to find out, okay, this is really all I need. Follow the recommendations and I'll stay right where I need to be. Don't add nutrients that aren't needed. They add to the salinity in the soil, and they can be environmental contaminants. And on top of that, they don't actually help the plants we're trying to grow. Keep an eye on salinity out here. If you're in way northern Idaho, there might, it might be a different situation. But for most of us in Nevada and Utah, southern Idaho, into Montana, salinity is something to keep an eye on. Remember, compost and manure are great organic matter sources, but they come with nutrients. So don't discard those. Think about, okay, I'm adding phosphorus with these. I probably don't want to add phosphorus fertilizer too. Think about other ways to add organic matter besides compost and manure. So cover crops are a great way to do it. Other things that you might scavenge, like fall leaves maybe, could be a good way. And then DIY compost is a great way to upcycle nutrients that you have anyway that would just be going into a landfill and instead can be turned into an amazing amendment for our soil that truly improves soil health. So with that, you made it. And I have a few minutes left for questions. Here's my contact information. So I'm happy to stay a few minutes after 2 and answer additional questions if you have them. But that's all I got.